All right, so what we're going to do here are the tougher ninja rule problems, which I call combo problems. They have the ninja rule in it, but usually they're going to have another rule also. So we've already done normal ones. Just a quick example. Um, if you had something, like y equals, let's go with 4 times x to the fifth minus 6x plus 2 raised to the third, right? If I had something like this and I went to take its derivative, you would treat it like, I'm going to switch colors here, you'd say, well, that problem's an awful lot like this guy. Especially if I cover that up and use my imagination, right? Wherever my fingers are, it's just like 4x to the third. It's 4 something to the third. Well, how do you take the derivative of 4x to the third? You go 3 times 4 is 12x to the second. And that's how you start this problem out. You're like, okay, 4 times 3, 12. This thing, I know it's not an x, but I can pretend. To the second. Now here's the catch. If you did that, you would have gotten ninja'd. Okay, and getting ninja'd looks sort of like this. You got draw a little ninja here. You got his little that. His little headband on. And he's sneaky. Right? He just sneaks up on you. Get you. Says, yeah. Right, here's the ninja. Sword. Okay, and he kills your grade. Because if you, get the red pen here for a little added threatening feature. Because if you forgot this at the end, it wasn't just x to 4x to the third, it was 4 something crazy to the third. So if you ever have a function inside of your function, you can't just do the normal derivative. You have to have this sneaky little thing at the end, which is the derivative of what was inside. And what was inside was this thing. So what's the derivative of that? 5x to the fourth minus 6. And I couldn't imagine doing this thing. The long way wouldn't be so terrible, but I still don't want to foil that out, and shoot, imagine doing that the really long way, like limit definition derivative. Okay, so now let's take it up a notch. That was just a normal, ninja rule. So let's take it up a notch and do a ninja inside of a ninja. So here is a ninja inside of a ninja, or as I like to call it, Russian nesting ninjas. You ever seen Russian nesting dolls? Well, you'll know what I'm talking about. I had to have some coffee there. It's delicious. All right, so what you should see here is this behaves at first like x to the fourth. Because if I covered up the inside, you're like, oh, that's just something with the fourth power. So you start off the problem the same way you would with this. And then you're like, oh man, it gets crazy. And it does. So I start off with 4 times this thing to the third. You really have to resist the temptation to do anything to the inside. It's probably the most common mistake. If you guys get all in a rush and you want to start taking the derivative of the inside right now, you got to be patient, right? This guy turns into 4x to the third. It doesn't turn into 4 something else to the third. It's 4x to the third. So when you first write it, it's 4, since it was this thing to the fourth, you got to do 4 times this thing to the third. Now, since you notice there's something inside, you're like, hey, there's something inside. You want to say, okay, I'm going to take the derivative of it, just like we did up here, right? But here's where it gets crazy, because inside here, there's something with an inside. So if I put my finger here, when I go to take the derivative of this part, I would treat it like x to the second. So I go, okay, 2 times this thing to the first. I didn't leave a lot of space because I already know the derivative of 7 goes away. It turns to 0. That's not a prime, that's a first power. And remember, I'm not changing the inside, just like I didn't change the whole inside here the first time. I'm not changing the inside of this guy. It's 2 times this guy to the first, right? But then you're like, wait a second, that had an inside. So my inside had an inside, and I need to multiply by the inside of that. You should see these problems when you get like trig functions involved. I don't know if we'll have enough time for that this year, but trig functions get kind of crazy. So this is sort of the end result. Now, if you wanted to clean it up, you could. It would not be pleasant to clean that up. So we're going to stop there and call it a first step derivative. You can see how this would get crazier and crazier. You can have like 3 of them in a row. You could have a ninja and a ninja and a ninja. You know, you can make this go forever. So let's do a different combo problem, because that's what I call a double ninja. Okay, let's do a different one and see if you can start to identify what type of ninjas we're dealing with. Okay, so this next one, I'm not going to title it yet because I want to see if you can tell. Y equals that one. Made that up, but it looks good. So if you ask me what this problem was, to me, you know, I kind of blur my eyes out. I don't know if you guys can do that, but if you ever sort of blur your eyes out and don't look too closely, to me that looks like a product rule. So I'd say, hey, it's a product rule. With, and you're like, uh-oh, shoot, that's not just something times something, it's something to the 4th. So I would call this a product rule with a ninja inside. Not to be confused with a ninja that has a product rule inside, which is also a thing, by the way. We can do that next if you want. So if I looked at this, it's a product with a ninja inside, and the reason I want you to name that carefully is because if you actually spend time to look at this and say that's a product with a ninja, it tells you how to solve the problem. Okay? It tells you how to solve the problem. Because when I use product rule, I call this guy U and this guy V, and I do my product rule, I'll say U prime V plus V prime U. Right? Okay, let's do it. Now, I already know when I go through this process, you should already know which one is going to be the bad step. That's what I like to think ahead. You know, you got to plan ahead. Just like I planned ahead for having the perfect amount of space on this page. So when I look ahead, I'm like, oh, the only thing that's bad about this problem is when I go to take the derivative of this. So I'm like, this is my danger zone. Danger zone. So that's the only hard part. The rest of it's pretty easy. So let's do it. Let's take the derivative of u. Okay, I go to take the derivative of u, which is 4 this thing to the 3rd. And then since I don't want to get ninja'd, I want to get assassinated, I multiply by the derivative of the inside, because it wasn't just 4x, or it wasn't just x to the 4th, which would have been 4x to the 3rd. There was an inside, so I have to multiply by the derivative of the inside. Okay, so it's u prime times v, so you got to be able to, you know, just write v, don't do anything to it, plus v prime times u. Now v prime is not a ninja rule. It's just a regular old 10x. It's just to take the derivative. Times u. Now do I need to do the derivative or the ninja rule on the back? No. You know why? It's not being differentiated. Or you're not taking the derivative of it here. So I only need to do that rule when you're taking the derivative of the ugly part. So that right there is it. It's not bad, right? Not bad at all. But it's important you knew that was a product rule with a ninja inside and not the other way around. Because this other way, you can do one. I'm on example 4. You know, plan ahead, like I said. Okay, so this one. I could do a ninja with a product inside. And what that would look like is something like this. I mean, there's lots of ways you can draw it. But overall, I would do something, you know, to the 4th power. And then I'll have a product rule inside. So maybe I'll have, you know, 4 x plus 3 times 6x squared minus 8x, and then I'll put a plus 1. Okay, so if I look at this, overall I kind of blur my eyes out and I see just a big old thing to a power. So to me that's a ninja rule. Okay, so how do you treat it? You treat it just like a normal ninja rule. You're like, oh, it's like x to the fourth. So I'm going to go 4 times this monstrosity to the third. Oops, 4x plus 3. Now, could you have FOILed that out? Probably. So 4x plus, or 4 times this thing to the third. Notice I didn't change anything inside. And then times the derivative of what's inside. So when you go to take the derivative of what's inside, that's not bad. And that goes away. It's a 0. This thing is bad because you're like, oh, no, this is u, and this is v. Holy cow, that's going to be ugly. Right? But that happens sometimes. You got the derivative of the inside. So you got u prime, which would be 4, right? U prime. V, so you just write v, plus v prime, right? V prime is 12x minus 8 times u, which is 4x plus 3. And I already did the derivative of 1 is 0, so that kind of went out of the way. This is your derivative of the ninja with a product inside. All right, so let's do one more, because I know you're waiting for it. You're waiting for some, you're waiting for a quotient rule, I know it. How about a quotient with a ninja? All right. How about a quotient with 2 ninjas? Let's get crazy. Hold on, let me write this, not to waste time. Okay, so if I wrote this one, to me it looks like a quotient rule. And then I'm like, oh no, I got a ninja on the bottom. Oh, I got a ninja on the top. That's a function in a function. It's not just square root of x. So I call that a quotient with 2 ninjas. And the first thing I do is just rewrite it. I would want to write this as the 1/2 power. Okay. There we go. All right, so second thing, now I'm going to start doing, what am I going to start doing? The quotient rule. Just like last time we started doing the ninja rule, the first time we started doing the product rule. So quotient rule, that's low D high, all right? So low, I just copy, let me look at this as low. Low D high, so we're going to go just copy the low, times the derivative of the high, that's 1/2 2x plus 6, and then to the negative 1/2. And since it's a ninja rule, you have to also go times the derivative of what was inside. It's just your D high is going to be weird. Same with your D low. Low D high minus high, so you just recopy this as 2x plus 6 to the 1/2. D low, derivative of low, would be 5 times this thing to the 4th, and then since it has an inside, you have to multiply by the derivative of the inside, 3x squared minus 5. All over low, so that's not bad. X cubed minus 5x to the 5th to the 2nd. You could write, you could write to the 5th and then to the 2nd, but if you raise a power to a power, you could just multiply it too. So to save some time or some ugliness, I mean, it's already ugly, but holy cow, that was pretty awesome. Now you shouldn't be scared of these. You could have something crazy like, oh, this is a ninja with a quotient and a product rule, and I can get real crazy, and I probably will. So you watch out. So yeah, hopefully this makes sense to you. If you're good at the basic rules, just know your worksheet that goes with this. Only do the first step derivative because these are terrible enough on their own. They're kind of fun when you're done with them, as long as you don't have to simplify. All right, hope that made sense. Talk to you later, people.